We also have
recording is on.
Oh.
I also
Okay,
Recording is on.
Showtime.
So maybe before I start with my formal presentation, maybe everybody can briefly introduce themselves to me, because I haven't got to know you yet. Just with one sentence.
I see we also have Xiao Jingfen here. She's from NTCRI.
Hello. 你好。
老师要不要开视讯？Maybe King. Hello. So this project we work with Taiwan National Craftsmanship Center. And Ms. Xiao represents NTCRI.
Nice to meet you. I heard a lot about your center from Abao.
他说他从我这边听到很多公益中心的故事。
我们说中文。
OK, hello.
我的中文不好。
你好。
你好。
你好。谢谢你。
So how about you just give me a call when you think I should start with my kind of presentation? But again, I would like if just everybody who is now in the talk would just briefly say hi to me, so I know I'm not talking to kind of a wall of the internet. So I'm a bit aware of that. There is some people listening.
Maybe. Yeah, I know Felista and Li Minchong. Do you want to say hi to Mark?
Just to motivate me a bit, huh?
Hello,
Hi,
Mark. Hello. We just need a moment because everything takes time to delay on the internet. So everything is slower to enter the conversation.
Exactly.
I live in Miami. I am looking forward to hearing from you.
Thanks.
I just know first she studies the oil. I'm also interested in her field.
Oil.
Yeah. I don't know that word.
Petrol.
Petrol.
Maybe that's easier.
Yeah, good. So you just you tell me when I should start about.
Okay. And we also have Wei Di Lian here. He just got in.
Super.
He's an indigo dye artist from Taiwan. 那个连威迪，我们现在在稍微介绍一下大家，因为那个讲者想要认识大家。
Oh, very good. Yeah, welcome. I think we have enough people to get started.
Okay, please.
Some opening word about?
Yeah, I knew Mark in China once in Shenzhen. It was his organization. It was his event. He organized this event called the Gosh, gathering a open science hardware. So that's how I met him. And then I knew him as a nomadic, a workshopist. Anyway, he's going to show us some nano witchcraft, but I'm more interested in his journey and his friendship all over the world. He kind of had built this network or friendship zone by sharing knowledge. And he took me to many places, and I'm very happy to have him here to share his personality and everything.
Thanks. I will try to share as much as possible. Yeah, so hello, everybody. As Abao said, my name is Mark. Just briefly, how I was seeing this presentation is that I will introduce also myself and a bit my practice within the Hackteria network, because it's related also to I think, this project. So 1/3 will be an overview of my activities and this Hackteria open source biological art network. And another third is like going a bit more specifically into some nano hacking, some experiments we have been doing, like using this hacking mindset and do-it-yourself mindset, also for nanotechnology. And the other third is your part. So whenever I say something and you don't understand and you want to know more, please raise your hand and Alba will then maybe stop me. And we can maybe look at one detail a bit in more depth, or we can also maybe translate a few things that I say in Chinese. I will go very, very fast. So the idea is just I give you a very rough and fast overview of some activities I've been involved and projects, so that we can then pick one or two later and go in more depth, the ones you are interested the most. Also, this should give you kind of an overview of some projects that I was involved, also some expertise I have. So in the upcoming couple of months, when you continue on the project, I'm happy to assist as an advisor. If someone has an idea about some material science or nanotechnology issues, you can also just call me with some whatever call. My contact should be somewhere on the hackpad that Alba was sharing. Did you understand this kind of framework? So 1/3 of the presentation, or this 1 hour, should be moderated by you people, like saying that I want to know more about this, and then I can go deeper and explain something in more detail. So I start, and also I have 2 screens. You see, there's only one person that is called Marc, that's me. But you see, if you click on the right windows, you see another Marc. You see that? Just nod your head. I will use one now to share my slides, and on the other one you will still see my face. And a bit later in the presentation, I will also show you some experiments that I have here on the table. Yeah, good. So I start sharing my screen now. So you should see the opening slide. And it's up to you if you want to have full screen on the slides or if you want to see all the other faces, it's up to you. So one thing I'm really enthusiastic about is what I call the laboratory. What is a laboratory? Can someone give me one word that comes to your mind when I say laboratory? Hello?
Right.
The first thing that comes to your mind when I say laboratory.
Tools.
Tools. Experiments. What else? Mouse. Very good. I show this photo specifically because I really don't want to focus on the tools or on the experiments we're doing there, or also the laboratory animals like mouse we have here. I think the core thing of a laboratory is the people that work in the laboratory. So the laboratory is just it's a place of labor. Labor means work. And the laboratory is where people work together using a shared set of tools, techniques, knowledge, and so forth. So the laboratory is a place where you work together. It's not the equipment. It's the place where people are. And because of the project's maybe complexity, you have to have a group of people. And on this photo, you see mostly women working in a laboratory from the middle-aged alchemists. And so we have to focus the laboratory and all this. I think it's part of this project as well. It's not so much about the specific experiment you do during the HFF. It's about having friends in the future. It's about the people that fill this void, this laboratory, with thoughts, with experiences, with human beings. Good.
Sorry, Marc, what is the name of that painting? Do you know?
I don't know. I think I just Googled like alchemist kitchen or alchemist laboratory, and I found this painting. Good question. I should figure that out. So this comes from the middle-aged alchemists, like before the scientific revolution. What I also like about this painting is that there is a window in the back, so the laboratory is open. The public can see what these alchemists are doing inside, and they had a strong idea of open windows in the alchemist laboratory. You know why? Not only because the people can see, it's just to not poison themselves. So there's like some ventilation. In the new laboratories, it's quite closed. And so with this kind of art and transdisciplinary laboratory, as the one I'm sitting here at the moment, I think this openness toward the public audience, towards the general public is crucial. So this is a photo of myself. That's me. I'm involved in many projects. One project is Hackteria. This is kind of a bit the framework where I'm presenting this today. And another group is the Swiss Mechatronic Art Society. It's kind of a makerspace community of electronic artists, geeks, and nerds that we run a space here in Zurich. And what Abba already mentioned, I'm also involved with a lot of global kind of organizations and networks and organizing meetings and conferences like the one in Shenzhen where we met, the Gathering for Open Science Hardware. I'm also building synthesizers. I have a company called the Center for Alternative Coconut Research. And some of the stuff I show is by my close friend and collaborator, Gaudi Labs, which is another laboratory in Switzerland that Urs is doing a lot of hardware development, and we work very closely together. Abau has already visited his laboratory, and he said it's even better than CERN. So this is like my first laboratory that I have been involved. It's a house I luckily own in Switzerland in the mountains. I call it Rande Lab. It runs on solar power. There is a toilet in the forest, no running water. And what you maybe see, if you look very closely on the photo, is there's a group of people. Again, the laboratory is not the equipment, it's the people that fill it with life and thoughts. And this was a typical event in Rande Lab. There's people from Indonesia, Nepal, South Africa, and Switzerland. So I think a lot of practice has been to connect and travel globally and bringing interesting people together that share a similar enthusiasm on let's say, transdisciplinarity, hacking, art, and social activities. What is this? The strange yellow room? Anybody has an idea what this is, these people? So in the years of 2000 to 2005, I was doing research in a kind of material science laboratory, specifically in a nanotechnology laboratory. So you see this laboratory looks totally different. Again, you see these people. Has anybody an idea why it's so yellow?
Avoid the UV light.
Very good. Exactly. So some of the process that we have been working with in this nanotechnology laboratory, they're very sensitive to blue light, to UV light. And so there's a lot of filters in there. So the normal lighting is more in this like yellow reddish wavelengths. Talking about nano, do you know what is the wavelength of blue light? Anybody?
Ooh, tough question.
Tough question. In fact, wave like the visible light that we see, it has a specific wavelength. That's kind of, you know, how many meters it is from one bump to the next valley to the next hill. And in fact, blue light is around 400 nanometer or 450. It doesn't matter the numbers. So we talk nanometer. When we talk about blue light, we already talk about nanotechnology. We talk about light that has a wavelength in the range of 400, 500 nanometers. And UV light, what we were just discussing before, has a lower wavelength, maybe 300, maybe 250. So in our daily practice, we talk a lot about nanotechnology when we talk about colors, for example. And this is a bit kind of the ideas I want to give with you. Nanotechnology is not something out of our human experience, it's something in our daily life, and we have been doing it since the beginning of humanity. But of course, working in a nanotechnology laboratory, myself, I was trained there. I did my research of my PhD there. It is a strange place, because why do I wear this protective suit? Not because I protect from myself from this dangerous nanotechnology. No, I have to protect the stuff I work with from humans. And so we emit so much crap all the time. We sweat, we stink. There is when we speak, there is rumors about all these particles that move out of our mouth. Like we talk about it a lot at the moment because of this corona kind of aerosols. So in a nanotechnology laboratory, we want to protect our experiments from human interference. That's why we wear this protective suit. So it's not to protect us, but it's protect our materials. Because one single breath emits thousands or millions of nanoparticles. I am a smoker, so my breath even contains much more of these small particles. And of course, if I work on a length scale of a few nanometers, let's say if I make a computer chip, and there is just a small piece of dust on my production, it will not work. So that's why we wear this strange clothing. As I said, feel free to interrupt me. I'm happy to tell more stories. So in fact, what was my maybe driving motivation for doing this kind of nanotechnology research was to cross different disciplines. I'm from engineering, specifically from material science, but I was interested to also bridge and work with other disciplines in the university research. I want to work with biologists, with engineers, people from manufacturing, and so forth. And so since this time in nanotechnology, I was really enthusiastic. How can we work together with different backgrounds? And nanotechnology is exactly where there is no more disciplines. And that's kind of an inspiring moment for me to find out that if we look at something on a very small scale, we will not see a difference between biology, between physics, between chemistry, and so forth. Specifically, I've been working on the interface. An interface is where two different worlds meet. So the interface of a material, this is a piece of metal or a piece of glass, and the living world, which is usually liquid. It contains proteins, it contains cells, and so forth. So my research was studying this interface where the engineered material reacts or interacts with the living world. And to understand this interface, we have to look at the atomic scale, we have to look at the molecular scale, we have to look at the macroscopic object. Examples of these interfaces are if you put something in your body, like an implant, a screw in your bone. Another interface is if you put a contact lens in your eye. So something will happen, something will interact. And it's not that the metal interacts with the body. There is a lot of layers of molecular interactions that we have to look at. And in the end, it is molecules that interact on many different length scales, but also on many different time scales. And just interrupt me. And I have a few examples also on the desk here that I can show you later. This stuff, if you do research in a kind of experimental research laboratory, it's not that I can buy something and do an experiment. I have to build the experiment myself. I have to build the equipment to do an experiment that has never been done before. So in fact, maybe the image you have of a research laboratory, nanotechnology looks really fancy, all this high-tech stuff, but in reality, we have to build our own equipment because we do an experiment no one has done. So the DIY method in certain disciplines are very normal. I was grinding stuff, I was gluing stuff together to build this experimental setup to test my kind of new processes. This is maybe something people don't get it. So the experimental research can be very do-it-yourself with all the problems that you have, like the glue will not stick and stuff like that. Specifically, I was looking at the interface of how cells, like living tissue, like a part of a body, like flesh, interacts on a piece of plastic. So I can grow these cells to make kind of a burger in a petri dish. But we were studying the very microscale interactions, molecular interactions, and so forth. And what I was personally doing was developing manufacturing processes, like do-it-yourself manufacturing, to make experiments how to study this interaction in 3 dimensions. So the cell, like the human body and each cells in us are 3-dimensional beings. So we have also to create an environment for them to grow that is 3-dimensional. So it was a lot of making small holes using high-end equipment, replicating them in polymers and plastics, coating them with different colors made out of proteins and so forth, and then using mostly microscopy to study these interactions. And this allowed me that on a microscopic scale, I have control over the areas on the nanometer scales where certain molecules are present, which then lead an interaction with living cells, so they grow in specific patterns. It's not so visible in this photo, but maybe you can see that there is two letters, an N and a W. This is like some kind of acronym. So I can make cells grow in specific places having certain shapes. So this is a bit what I was doing. And this needs kind of macroscopic control of nanometer molecular interactions. Why? Good questions. This we have to leave for another discussion. But some outlook at that time, like from 2005, that if we grow like living tissue, like parts of humans, like organs, a bit of liver, a bit of heart, a bit of brain, if we grow it on a chip. Are you still here, by the way?
Yeah.
Yeah, I need to plug in my power. But if we're able to grow certain organs outside of the body, we can maybe replace the human or the animal to do experimentation on. So we don't need the laboratory mouse, but we have kind of a artificially grown mouse-like creature on a chip that responds similar to, let's say, if we want to check for drugs or toxins and so forth. So that was the outlook from 2005. This still is gonna like happen in some kind of a future, but some of this stuff is real. So I have stuff here. I don't know if you can see this. I turned the camera a bit around. I don't see anything. Oh, I can't. Can you see this?
No.
On the other camera, not on the slides. No.
No.
Okay, let me get my. Am I still here with this second camera? So does anybody has a question? I tried to start the second camera again. I think it shut down.
Why the light was yellow, not red?
Yellow is kind of, it's already on the red side. So if we remove blue from the rainbow, we end up with yellow because we still have a bit of green, yellow, and red. So do you know what I mean?
So means it's safer. I mean,
just some of the stuff, as you said correctly, if it's exposed to ultraviolet or blue light, it will change its properties. And so we just don't want that kind of blue light.
We're going to get developed or something, no?
For example, for photography developers. So I'm. If you want to briefly maybe look at the second camera, you can click on the image where you see like stuff lying around. Are you there? So
yeah.
Look at the slides.
Yeah. So we should go. Yeah, I saw it.
Yeah, so you can switch to another camera view. You see some blue, and you see, for example, this chip. And in this chip, we can grow like living things, like cells or brains, to record stuff from them. So this is kind of an interface between the electronic world and the living world. And it's maybe difficult to see, but inside there is some computer chip, and outside there's a ring, so we can put some drop of liquid inside. And in this liquid, there will be proteins, there will be maybe brain cells, and so forth. So this is kind of nanotechnology because this interface that I mentioned before is very crucial. This molecular layer between the electrodes and the living world, this is where the interaction happens. And if we want to measure something with our technology, we have to understand this nanometer layer between our engineered surface and the big living world out there, which might be a cell.
So that hole captures micro voltage?
Yes, even smaller, I think.
Okay.
Electrically, we can measure ultra small stuff. That's not even the problem. The measuring of electronics is not difficult, but that interface to see and control what's happened there, have it stable over time, that is, let's say, the biggest challenge.
Why so many legs?
I didn't understand.
Why so many pins?
it's cool. I don't know. These are standard packages. Maybe not all of them are used.
Actually, it looks like a bit like this old EEPROMs with this.
Yeah, but here you put brain.
Yeah. No, but, I'm sure it's like a different, like application.
So this is the same technology but a different layout, and this is a similar technology, but do it yourself.
Nice.
So that's a bit what I now want to continue. If there is no question about this background of nanotechnology, I would like to go into the kind of other story. Are you ready?
Yeah.
Very good. I put this camera here again. Oops. I can't do it. Good. Good. And this a bit down. Yeah. So I continue. You see my slides. And so after finishing with my research in nanotechnology, through my interest in culture, in music, and interdisciplinarity, I kind of shifted and went even further into other disciplines. I was interested in electronic experimental music, and so we started a kind of community and a hacker space called the Method Lab in 2006. So of course, this looks now very different. So suddenly I leave these high-end laboratories and I started building kind of maker spaces with friends, with artists, with creatives, with musicians that like experimental music. So since then, we have this kind of active community. And in fact, now, since a few weeks, we have a new laboratory that I was involved in setting up, dedicated to the Hackteria open source biological art projects and networks in our new space. This is where I'm sitting at the moment. So I really like laboratories. On the lower part of the image, you see the whole space. It's a shared space as a hacker space collective with different organizations, with like a maker space, with like a digital kind of computer research lab, with a woodworking lab, but also a bio-nano chemical experimentation laboratory. And it's the first time we have a space dedicated for this. I don't know how much you heard about this biohacking or do-it-yourself biology, but for more than 10 years, there has been a global movement of hackers, makers, and creatives to not only work with, let's say, electronics or with computers, but to also work with bacteria and with genetics as a creative medium outside of the formal institutions. Building a biological laboratory also for genetic experiments, it's much easier than you think. It looks more or less like a kitchen. A lot of the equipment is relatively cheap to buy on eBay, on Alibaba, or you can make the equipment yourself. And so we started a project called Hackteria in 2009, which brought together the ideas of this biohacking and do-it-yourself movement, brought it together also with a more kind of creative and critical and artistic approach. So it's kind of artists working with biologists and hackers working with teachers. And because it's our foundation with Andy Gracie and Yasha Shetty, we had a strong foot in India, where we founded Hackteria. It's a friend of mine who works at an art school in Bangalore in India. So also, of course, what we have to do if we want to work on biology or nanotechnology outside the institution, we have to build our own laboratories. And building a laboratory, it's kind of a crucial step to take ownership of your experiments and of your skills. Instead of just going to a finished place, I think building a laboratory together is a very nice process to go through. Our first project was looking into kind of this do-it-yourself space biology research. How can life survive in outer space conditions? We kind of made we tried to mimic the light and magnetic fields of Jupiter or something like this. These are poetic projects, so they're not research projects. They're artistic, poetic projects. And our friends in India started to teach a course on genetics called Synthetic Biology for Artists and Designers at the same time. And we all came together and thought we should start a project called Hackteria, that should teach creatives, artists, designers, makers, teachers on these modern tools of biology, of the life sciences. Of course, experimenting with different ways of communication. We make graffiti to explain how we can make a bacteria genetically modified so it emits light. And personally, I added a project to this kind of knowledge starting point that we can also build equipment for doing microscopy. A microscope is maybe one of the crucial tools to see the small world. So one step towards the nanometer, towards nanotechnology, is building tools that makes us sense, that makes us feel, makes us see these phenomena on another length scale that is not possible to kind of perceive with our human senses. And a lot of science is about this instrumentation to extend our human sense. And so building microscope was my hobby for a long time already. And I have done a lot of workshops on using a cheap webcam, a $3 webcam, and turn it into a useful microscope to be able to see single cells, yeast cells, or many other things of your body. And this made me travel around the world, developing different methodologies for the workshop, different setups for the microscopes, and creative uses of this scientific instrument, the microscope, to use it in a sound performance, using for VJing and so forth. And doing these workshops in India, it was very inspiring to see that there is this culture of do-it-yourself, to use like a limited resources, but to come up with some kind of innovations or solutions, which is a project that is not called hacking. It's an approach that is called Jugaad. These are these kind of self-made cars from people that usually have no training as a mechanic, but they somehow manage to build a car out of stuff they find somewhere. So the do-it-yourself, the Jugaad, the hacking, these are all a bit different approaches on how I personally try to approach new projects. So Jugaad is this very kind of rough do-it-yourself. You find leftover things. And there is an example from our 10 years ago where we built something. It's called a thermocycler. It's something that can heat and cool very, very precisely. It's an important tool for every laboratory for genetics. It's called polymerase chain reaction thermocycler. And what you see on the top, this is just a hair dryer and an Arduino that controls the temperature of our sample. And on the bottom side, you see that for people like Gaudi Labs, they have developed these rough projects into products that are now sold and used in schools. So feel free to interrupt me. I should go a bit faster. These kind of projects, building synthesizers, building microscope, I got invited also to Indonesia, to Taiwan and other places. And from 2008 to 2015, I've done a lot of international collaborations, making these very do-it-yourself workshops on scientific equipment, on working with biology, but also on electronics. Another photo of like a microscope. So when we use a microscope, we suddenly see animals that we don't see by eye. And this is, by the way, a tardigrade. It's also the logo of the Hackteria project. Having a strong idea of sharing and open source. So one method of sharing, because it's not like digital code that we can copy. It's not open source that you just can copy my file. It's knowledge that we want to produce as open source. So we have to write instructions. We have to go physically to places and teach people on how to do stuff with the hope that they take this knowledge, change it, adapt it, and develop it further. Open source is not about copying something. It's about taking existing knowledge and adapting it to your own needs, improving it, and sharing that knowledge back into the original source or community. And this was happening. So building microscopes, our Indonesian partners have developed like more microscopes to be used at their university. They have, developed a product out of it. And that's the best thing that can happen. If someone takes an idea in an open source community and develops it further and even sells a kit out of it, your job's done because someone else has continued the project. It's much better than keeping the knowledge for yourself. Open source design also allows that there is many different versions of something. And maybe one school in one place prefers this way of doing it because they have this and that material available, while another place has other materials available. So having an open source community, it is much more robust that the knowledge can be used in different settings. I think I have to go a bit faster, so I just skip a few things. We have a website, we have a wiki for more than 10 years where we kind of put all these knowledges inside, where we document rough prototypes. It's not finished stuff, it's just like notebooks that we share with many. Oops, something happened there. Rejoin. Does anybody have a question to what I have been just showing? Hello?
It's too
much information.
For me, but I think it's some you show us some equipment to perceive to perceive information in different dimensions. But it's interesting, but we don't know the application. We are introducing as tools.
So I have been showing two things. One is the microscope. I think this is, most people know what it is. It's kind of a lens, a magnifying lens. So we can see more than the eye can see. We can see stuff that is so small, maybe only a few micrometers. We can see it visually because we use a microscope. And the PCR, it's how can we see a gene, like genetic information? We need this kind of tools. It's a combination of a heating system and some molecular kind of system. So a lot of when we discuss nanotechnology or genetics, we need these tools to be able to perceive the information from this other zone that our human senses cannot perceive. And microscope is one thing. PCR, like polymerase chain reaction, is another thing. It's also the same way how we can detect this coronavirus. This is the PCR method. So how can we see these small things, a virus that is only a few nanometers in size? So we need microscopes, PCR, and many, many other tools. And so a lot of these Hackteria workshops are introducing these tools to artists and creatives, and also demystifying them by building these instruments ourselves. This opens up a possibility also for a creative use. I can just use it. I can break it apart instead of having to go to a specialized laboratory and so forth. Which brings me to this question. Open source biological art. So on one hand, we just share instructions. It can be used by teachers, by independent researchers. But what is this art there? Anybody wants to comment on this? No? Why art? Because there has always been art. Like if we look back to the caveman, they had these paintings on the wall. So why should we do this biology and this research on nanotechnology without art? That would be even a stranger question. So in fact, all life, all human activity has involved art, and we should continue doing so. That's kind of an easy explanation.
It's like a culture,
So maybe art makes human activities, let's say science, into culture, because there is also some kind of culture and art involved, yes. Any other comments about that art thing?
Also, earlier you referenced the symbolic and metaphorical nature of some of your work, that it operates on a different scale than industry, or in a different scope and realm. So sometimes we can do things in art as a way to show possibilities for things that we can only imagine or are starting to create.
Mm-hmm. Yeah, I totally agree with what you just said. Anyone else wants to kind of comment a bit on this kind of why do we do this scientific equipment and this genetic manipulation and within these arts circles as well?
It's a bug in society. It gives you opportunities to get away from the system.
It's also true. But in fact, partially, partially working within this art context, it gave us a lot of freedom to really kind of experiment with weird ideas, to do something also that is not directly opportunistic for a product or for a new grant or something. So it gave us also freedom to experiment in these collaborative environments. And also there was not a huge, but there is a group of artists and creatives that want to work with these technologies and with these new knowledges of science and nanotechnology. And so we tried to provide it to them. And there is an interest, in fact, not huge, but there is some. And I think some of them are in this course. I think I have to skip. So we organized a lot of meetings where we bring people together in this global network, very much focusing on the physical presence and 2-3 weeks of working together across cultures, across disciplines, and without too much pressure of what comes out. But in fact, a lot of things came out, sometimes not at the end of these events, but maybe a year later, like new friendships, new projects idea that then were picked up in a collaborative manner 2-3 years later. We did events in Switzerland, in India, in Nepal, in Indonesia. And a lot of the spirit of Hackteria has been influenced by this global and intercultural dialogue, by also some work styles of India, Indonesia. And since 2-3 years, I was really eager to work on something together with Abao, also to organize something in Taiwan. We ended up in Okinawa. This spring, we organized a small event where almost no one came because of the travel restrictions. But somehow I think some of this idea of collaboration and kind of process, based camps, I think has also influenced our discussion with Abao and maybe also this project that we're all now participating. I'm having a short break, though this was the first part of the background. I've used a bit too much time. Does someone want to pick up a topic, or should I? Maybe it would be nice if someone says something so I can just get a bit of kind of air, a question or a comment to what I was just showing.
What about the materials, in the early days? How did you source raw materials and
Can you repeat the question? I didn't understand.
I asked what about the materials you were using, your early days of the Hackteria and stuff like that. How did you actually source them, or did you make them yourself?
I'm very broad, but I think finding the materials is one of the key skills that you need to become a bio-nano hacker or something. And it's something very difficult to teach people. It's a skill, and we do this at workshops. We go, for example, to the flea market, and we talk about the stuff we see there. We share distributors where you can buy certain things, and also just motivate people to use the daily, everyday materials they find around them, and open up that idea. You can go to the trash, find some old computer equipment, some fans, some motors, some kind of webcams, and you can start to build a biological laboratory. So I think it's difficult to convey this message that if you don't have a material, you can find it somewhere. That's maybe the hacking mindset a bit and the DIY mindset. And a lot of people, maybe an artist without a training in biology, it's very distant to them. And so we want to make it closer by using this recycled material to build equipment, by using household objects and so forth. Does that explain a bit your question?
Of course.
But certain materials are difficult to get. Certain but it's something why these groups are very important. So we can share, I found this, you can order it there. But of course, what you can order in US is not the same what I can order in Switzerland, in Israel, or in Taiwan. So this is also local knowledge. That's why a space like this is important to kind of, where did you find this and stuff? So any other question? Otherwise, I go a bit into some nano hacking experiments that we have been doing. Is that a yes?
Yeah.
So I tried to put this camera again on my stupid holder. But do you see the second camera again?
Yeah.
So you can maybe also see my face here. So maybe you should not see at the share screen, but you should look at my live camera at the moment. So maybe a brief exercise. Can everybody that is still listening, tell me something that comes to their mind that has somehow something with nano in the name or in the use or something? Or what does it trigger? What kind of keywords does it trigger when you hear nanotechnology? Maybe everybody.
Like the stuff that you cannot see.
Small.
All the stuff that you cannot see. Good. More ideas, more keywords. Or maybe a specific technology that has something to do with nano that comes to your mind, or an application.
Nanobot.
Yes.
Nanobot. Very good. Anybody else wants to comment? What is a nanobot?
Like a tiny microfluid.
Tiny microfluidics. Mm-hmm. Do you know something that has the word nano in it, or
Something like a nano coating?
Nano coating? Very good. Yeah. So these are these very thin layers, maybe a few nanometers, that change totally the properties of a surface. Very good. I have something here. I don't know if you see it. Anybody knows what it is? It's a capacitor.
White capacitor.
A basic electronic component, and it says here nanofarad.
Ooh.
So what I want to say is, like, nano doesn't mean anything. It means kilogram, microgram, mega. It's just an order of magnitude. So if it's something is really small capacitor, it's nanofarad. There is even more. There is even picofarad, but we not talk about pico technology or nanotechnology when we talk about capacitors. But all that nano means, it's 1,000th of micro. It's 1,000th of one, or milli exactly, and it's 1,000th of just basic units. And when we talk about nanotechnology, in fact, we're not talking about any technology. We talk about nanometers. We talk about the length scale, like how big is something, and it's really, really, really small. So one person already said what comes to her mind was small. That's all it is. There's no magic. There's no special technology like a motor or something. We just talk about the very, very small thing, or phenomena, or object, or interaction, or layer. So there was a bit of a misunderstanding, because we say nanotechnology, although there is no technology. All we talk about is nanometer scale. All the stuff you see on this table is big, but we have a lot of course, phenomena that we can observe that happen on the nanometer scale. And so maybe we can go back to the slide. The slides, you can click somewhere and you see again my shared screen. There should be something written. Small is beautiful. Yes, I agree. Everybody can make things bigger, more complex, and more violent. It takes a touch of genius and a lot of courage to move in the opposite direction. This is from economics, but anyway, it's just a quote. So what I just mentioned, nanotechnology is not really a technology. It's all the technologies involved, all the equipment involved, all the phenomena involved that happen on the nanometer scale. How we can see stuff there, how we can modify, manipulate stuff there, how these phenomena on the nanometer scale have impact in daily lives and so forth. So, in fact, it's better to call it nanosciences or something. There is no technology. This one also shows it properly. So this is in German. Faustkeil is the hand axe, this kind of caveman tool. Later we had the steam engine. now everything is nanotechnology, and this in fact is an advertisement by a construction site. So nanotechnology is already how the local construction company advertises themselves. So it's totally out there already. Paints, in the way we kind of communicate in our computers. It's not something new. It's totally already abundant everywhere, and it was for all the time. What do we see here? Looks weird. This is, I've tried to pick up a topic from also traditional crafts. This is something in a museum. I think it's made 2,000 years ago in old Rome. It's a glass cup, if I'm drinking glass. And if depending on the light that goes through it, it can shine in red. And if the light comes from the other side, the color changes in blue. And these are traditional glass making. There's a lot of ways to make color into glass. And in fact, these colors, how do you think you make these colors? With pigments? No, sorry. For all the pigment geeks in this group, there is something much, much smaller than normal pigments. It's called a nanoparticle. And in fact, it's in a way too small to act as a color like a pigment. But somehow, because it's so small, on a quantum level, it interacts with light. And these different colors that you see here on the next slide, it goes blue, there's like some green and some pink and some blue. This is all the same pigment. It's not a pigment, it's a gold nanoparticle. So we have gold in such a small scale that it's only a few hundreds of atoms of gold, that it interacts with light in a very different manner than your normal like indigo pigments. And so with the same material, depending on the size of your nanoparticle, you can change the color in all different colors. And so this is a phenomenon that has been used in glass making for 2,000 years already. They didn't maybe understand, but they just grinded a bit of gold, dissolved it in something, and I don't know, did something, and suddenly the color changed. And with the same source of gold, to changing the process a little bit, it might be red, but can also be blue. So this is something I wanted to share with you to kind of connect a bit to some of the traditional craftsmen. So nanotechnology and using these phenomena on the nanometer scale, it's something we have been doing for the age of humanity. Someone mentioned also the stuff that we cannot see. On this graph, on the right side, you see what we can see. So we can see a frog egg. We can see an individual hair. This is like about 1/10 of a millimeter that we can see with the human eye. We can use a microscope, it means an optical microscope, and we can even see something that even less than 1 micrometer. And all life forms are bigger than 1 micrometer. Bacteria or cells or yeasts, they're like 10 microns, 2 microns, 100 microns, and so forth. What we cannot see with the microscope is a virus. They're even smaller. They're maybe 100 nanometers, 10 nanometers. And dealing with viruses, is that nanotechnology? Maybe not. That's just human immune system. So we already interact with a lot of stuff out there using our immune system. Our body is built from cellular blocks, from DNA, from proteins, and so forth. So there's all these other molecular interactions that fundamentally influence our life. And of course, we can feel a virus because we get sick. So there is interactions happening on the nanometer scale that have a human global level impact. But what we have now, so when we say nanotechnology, we have since the 80s, we have built new tools, new, better microscopes. They're not optical microscopes. And suddenly we can visualize and get information from this small scale. We have even tools to poke it, to push it, to feel it on this nanometer scale. We have new manufacturing methods to produce components on the nanometer scale. Modern chip manufacturing that you have in your computer, the structures on there, they're like 5 to 10 nanometers in size to build billions of transistors into your mobile phone. So if we look at the next slide, what I said in the beginning, the cool thing about the nanosciences is that all these different disciplines come together. Like the manufacturing and engineering, now we can build computer chips on that small level. Chemistry has always worked with even smaller things, with molecules and atoms. Biology already has this kind of cellular structures and proteins and viruses that are in this same length scale. So when we look at this length scale, what happened in the last 20, 30 years is that we suddenly start to use the same tools and start also to use the same language. And because these disciplines move together, this allows us, and maybe that's the most interesting thing about nanotechnology, to integrate all these knowledges into new applications, into new knowledge, into completely maybe unforeseeable futures. Does anybody want to comment on that? Someone said nanorobots, and I gave this little bit kind of convergence of different disciplines that I'm very interested in. Here are some pictures of nanorobots. These are kind of famous on the internet. Anybody wants to comment on those nanorobot photos? Maybe not. These are totally sci-fi crap, if you ask me. If we build robots, which means engineered systems, on the nanoscale, they will not look like spaceships. They will not look like a machine. They will not look like gears and cogs. They will look like the existing biological structures that we already have out in nature. They will look like soap bubbles, like cells, like viruses. And so a lot of the science fiction imagination looks too much into this engineering mindset from the 20th century, building rockets, big machines and cars, and just makes them really small. And I don't think that's the way nanoscience is pushed forward. It is from inspiration from biology that already always worked in the nanometer scale. All our cells, our immune system, our genetic cell multiplication works on these nano levels. Anybody has a question? So from 2010 to 2012, and since then, we have explored this kind of, can we do it yourself? Can we use hacking strategies also to work with these nanomaterials? Not in the high-end laboratory. And in these collaborative labs and processes, mostly in Slovenia, we called it nanošmano, nanopunk, and hacking of the future. We explored together this very household approach to nanotechnology. It was a collaboration, again, a very collaborative and open culture mindset with artists, poets, musicians, other researchers, hackers. These are just some photos of the people involved. And we look a lot into the history also of microscopy, of seeing things. And we wanted to explore how can we see these phenomena or these materials on the nanoscale? How can we feel it? How can we perceive it with smell and all our human senses? And of course, beyond the microscope, there is always lasers. Laser is the key instrument to see effects on a nanometer scale. And it's very, very easy because a laser can magnify a phenomena a lot. If you point the laser towards a wall and the wall moves a little bit, the reflection of the laser 1 kilometer away moves a lot. So you can magnify movement by just shining a laser on it. And if you look at this first scientific equipment to manipulate and observe matter on the nanometer scale, these are totally self-made objects, some tubing, some duct tape, and they just put it in an oven or something. So this is the first atomic force microscope. As I said in the beginning, experimental research in a research laboratory, you have to build your own equipment because you do an experiment no one else has done before. And to reflect on this feeling, how can we feel, how can we touch a material and perceive its nanometer phenomena? This is what an atomic force microscope does. It touches the surface. We can maybe do something like an acoustic FAC microscope. So we point a laser and we focus a laser on a record player, and we look at the reflection. By looking, I mean we add an electronic sensor, and suddenly we can hear the music. And if you look at the record player, these are microscopic like structures, but we can use a laser to make it audible instead of mechanically like a normal record player works. How can we move things on a nanometer scale? I think a lot of you know, some of you maybe know what is a piezo microphone or piezo speaker. There's also one here. Have you used piezos before? I know you have, Abao.
I've also used. Sure.
Why do I bring a piezo into nano hacking? So we can make sound with a piezo speaker. We can listen to sound. In fact, there is a material, a crystal, that is called a piezo crystal. And if we apply a voltage, let's say 3 voltage, it expands or it shrinks. So it grows. And it grows just a few nanometers, in fact. So when I put voltage on a piezo, the crystal there, the material will grow maybe 100 nanometers. So there you go. You have nanotechnology on your desk. So what we did is we scratched a piezo. So we have 4 parts of it. And then we apply voltages to these different corners, which means it's not just grows, it also kind of warps, it deforms. And we put a little needle on it in the middle. So we can start to move a needle like sub-micron resolution. This is like just done with a piezo and some hot glue and 4 wires.
So in this case, only 4 direction?
It is totally random. It's not random, but it's not controlled. But we can move. We warp it, so it kind of moves this. Maybe can you see this? So it just moves somewhere. I can go there. I can go there. I can go there. I can go there. I can go a little bit up, a little bit down. But this is so small. But we can magnify this 50 nanometers movement of the piezo by making it warp. So then a long stick will make a big movement, and the short stick will make a small movement. So we were experimenting with all this stuff. So there is this 50 nanometers piezo movement. By adding a stick and these 4 corners, we can make it visible with our eyes that we can move it. But it's still ultra precise. Any other questions to then what?
Sorry, but what is the relation between these 2 pictures?
It's on the right side. This is like, how you call it? This is mechanical magnification. So when something moves here, really small, here, really big, a lever. And the machine on the right side, the movement on one side is massively magnified on the whole wheel. So this is like an old mechanical, I don't forgot the name of it. You move something really small on one side, and on the other side, it moves a lot mechanically.
It's like a pantograph or something,
Exactly, something like this, yeah. And I don't know, this is some kind of middle-aged machine to also magnify mechanical motion. Any other question? We also build crazy, useless stuff like Nanokunst. Kunst is the German word for art. And we work with more other nanomaterials. We build our own laboratory in a public bar. We invite more hackers and researchers. And again, we want to perceive with our eyes these nanoparticles. How do they sound? Can we use it for a sound experimental music performance? How do they smell? And in fact, how you want to see a nanoparticle, you have to go really, really close. That's how to do it. And I mentioned before, light does interact on a nanometer level. Light itself, the wavelength is on a nanometer level. That's why we see rainbows, by the way. Anybody has an idea why there is no pink in the rainbow? Why? Why is there no pink in the rainbow?
Because
difficult question.
Because it's political.
There is no pink in the rainbow. I have looked at many rainbows.
You don't say that.
There is no pink in the rainbow. The color pink does not exist in the rainbow. And it's my favorite color, so I really miss it. I like rainbows and I like pink, but they're not both in the same group. Yeah, we have to figure it out. Maybe you have some time to figure out why there is no pink in the rainbow. And we also grow materials, like we use biology to grow nanomaterials, and we make circuits, electronic circuits, that make us also perceive these nanometer changes, these different surface coatings, these layers that we can add. And this is a last experiment I want to do with you. With this, I'm kind of done with my slides. So I maybe even stop. I leave the sharing on. So it's all right, already an hour gone. So we have started a bit later. What's the time about?
It's 11:12.
Okay, so we're kind of an hour because we started 15 minutes later. So I think everybody should switch to my video camera. Then you can see my work desk. And you can maybe comment. I will just do something a little bit. Maybe you can ask another questions or give a comment. There's a lot of information, I know, but this is how I do it.
Why you choose to study nano, and what was your first nano experiment or nano art?
But I think I mentioned something that was interesting for me was this very interdisciplinary character of material science. It's not, chemistry, it's chemistry, physics, and this same idea of interdisciplinary or even cross-disciplinary, this drove me to this nanotech, because this is where all these different disciplines meet. And maybe the same drive to go into these different disciplines and make people work together from different backgrounds drove me into my current activities as a global kind of hacker, artist, organizer.
Yeah, and then I also have some question that then for you, the Hackteria is like a hobby for you, or what's the aim for the
No, it's
Hackteria?
my main mission. It's where my heart is.
Okay.
They always told me when I was young, it would be great if you can make your hobby your job. I did long time ago. It doesn't mean I get a lot of money and get really rich, but I think I made the hobby my job. My job means my main activities, my main daily activities. I really organize workshops, set up hacker spaces, write grants, travel around the world, give talks, experiment with other crazy, enthusiastic people. Yes. Also involved in some local hackerspace. I teach once in a while at universities or in informal places.
But then you're not doing anymore the serious nanotechnology, or are you still?
I think it's even more serious at the moment. What means serious?
Okay.
I don't take life too serious, but I think it is serious. If you bring these technologies to the real people, I think this is a serious job to do. Doesn't matter if it's paid or if I have a work contract and if I write scientific publications. I do think this is serious business. I maybe make a lot of jokes, but making jokes means it's serious. What is this?
Candle.
A candle. I showed you before a bit some of these like high-end brain interfaces. Let's put them onto the way. Also, this I showed to Abao. So this is an implantable brain interface to remotely control a rat. We made this with silicone and conductive ink. It's like handmade in the laboratory for a single prototype experiment on remotely control the rat. There's only 10 electrodes that you put somewhere in the brain, and it's kind of a flexible, stretchable silicone kind of. Oops. Yeah. So this stuff is what we do in our lab. We have to build these devices.
Do you have a rat around?
Sorry? I don't have the rat. So this is an old prototype I just have in a drawer just to show people that we can build this neural implant. Not only Elon Musk can do it. And we have done this already 10 years ago. What is this? What is it?
That's the word.
A prism.
Yeah, a prism.
And about 500 years ago, people have found out something really, really strange. I don't know if it's possible. But if you look through a prism at a single point light source, like a candle, you see a rainbow. So suddenly we can observe with our human eyes tiny differences in the wavelength, a few nanometers of differences in the wavelength of light. So we see blue and red there. But we don't see pink, but this is another thing. So very simple object like this can give us some information on the nanometer scale. We can maybe also see, let's say, if we look at the color I showed you in the beginning of the gold nanoparticles or of your pigments, these are nanometer effects with the gold particles. With a prisma, we can see this, and we can just put light sensor here. And this is made out of plastic, by the way. I order it for $1. And so then I have something else here. It's a circuit, the one that I showed you on the slide. It's a very simple oscillator, electronic circuit. And when I press here, you hear this? So when the resistance changes on this between here and here, it creates a tone. If the resistance is really low, the electric resistance, the tone goes really high. And so if I touch it, you hear this? So I put it here on these two pads. So between here and here, that's a bit difficult, huh?
But this is not nano.
Why is it not nano?
Where?
So look what happens if I blow on it. Zoom it here. Or what happens if I grind it?
It's like a pickup.
Or what happens if I take it in my mouth? You hear this? So I just blow on it.
So before you sand it?
Yeah, I had to sand it to get a nice surface. Maybe I lick it. So what do we hear? Why do I hear this when I blow on it? Any idea why can I hear this when I blow on it?
Because it's like a resistive. No?
Yes. So there must be something here that is a resistor. And when I blow on it, this resistance goes down. What could I do with my blow? I ate Indian curry for lunch. I don't know if that matters. So there's something in my breath that changes the resistance on these two copper pads or in between. I have no idea.
Oh, that's new to me.
Yes.
I guess your breath is like wet a bit, you know. So like,
what did you say?
That your breath is like a bit wet, and then you get some.
I think you would just want a price. I also think it has something to do with the humidity. When you blow on a piece of glass, you know, you see this water condensating. I also think I blow here, and a bit of water from my breath will condensate on the surface, and it will change the resistance, because there is, from the grinding, there is already some stuff, and maybe I licked it before it. You need to kind of prepare the surface a little bit that this is possible, but very small kind of change in humidity from my breath is or something. And the layer of water that I put there, it's very small. It's a few molecules of water, maybe 100 nanometers of water, and it instantly evaporates. It goes away. So let's make something else. What is this? A candle. what can I do with a candle? I can burn it. And what comes out above the candle? Heat and some other shit. You know what happens when I cool down a candle, a flame, a candle? So when I cool the flame, I put some piece of metal, a scissors inside. It starts to smoke. Black smoke comes up. I don't know the Chinese word for this black smoke. How's it called in Chinese? In English, it's soot. What is this black stuff that comes from the candle?
Yan tan.
So if a flame doesn't burn properly, there is this black stuff coming out. It's called soot. And I can use this to coat my circuit now.
Or carbon layer.
Yes. And now you see it's a bit black. And the tone is fixed. It's really high tone now. It's not going away because it's now this resistive. This is very thin layer of carbon we put there. But let's put even more. Now it's really a terrible high pitch. So I just clean it away again.
Nice.
So we have just done some nanotechnology. We applied almost nanoparticles, like we applied a lot of particles of carbon from the black stuff. There is microscopic particles, but there is a lot of nanoscale particles in this black stuff, a lot. We put them on this, we created a very thin layer, and look what happens now. Failed. I had to do it again. I cleaned it too well. So if there is this carbon layer on it, I can blow on it as much as I want. Doesn't matter anymore.
Okay.
So because we have this very thin coating of carbon, the water will not go there because water doesn't like carbon. So again, so these are very simple experiments. So we can change the properties on the this terrible sound. So it doesn't work so well anymore. It kind of does. So by changing the surface with this hose, with this black stuff, it doesn't like water anymore. So the water from my breath will not condensate on the surface. So we can, these are nanometer coatings that have a real world impact. So I think I play a bit more with my candle. Until it's totally black. Nice black, huh? And of course, if I put water over it, it will just boing, 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 boing. It will just drop over, because it doesn't like water. That's why my breath wasn't changing the resistance anymore, kind of. Yeah, well, so these are these experiments I'm trying to do, working with nanomaterials in a very household and very kind of direct, accessible, trashy matter. With this experiment, I'm kind of over, and I changed this camera to my face. So now it's your turn. Maybe you can make me tell more stories, or give me some maybe interesting insight. There is the lab. Yeah, I hope I have confused you all a lot. So now it's up to you maybe to give me some questions, or maybe to repeat one part of the story where I was before and go in more detail. I will not continue talking until you tell me what I should say.
You can tell us on what you're working now. these days?
I can. So, in fact, I work a lot on this. The whole space.
Nice.
So we just moved in here a few months ago, an empty space, and I have been very physically manual labor, building walls, painting, moving around furniture, repacking everything to set up this new space, which was in fact fantastic in all this kind of online presence and kind of not being able to travel. It was really good to materialize some stuff, and we can be here for 5 years and finally set up this laboratory, sorting all the components.
So can we build an 80 tiny from scratch at your lab?
I would love, so like making computer chips, making transistors is in fact at the very fundament of nanotechnology. And the drive came from manufacturing, like sensors and rockets and stuff, and making household computers. But the tools developed for making these small chips, like an tiny, like an integrated circuit, these are exactly the tools that led also to what we now perceive as nanotechnology, because we wanted to have more precise knowledge of small semiconductors. So in fact, I think the history of nanotechnology starts with integrated circuit electronics manufacturing. I know it would be nice, but I think to make our own transistor, one single one would already be good enough. I think we should start now with a whole kind of microcontroller.
Yeah, I guess the diode is like the start, started from the diode, in the end.
I want to try something. What happens if I start this microphone? Can you hear me?
Yeah.
Good. So I'm now using the microphone from my. I need to turn off the other microphone.
Echo.
Sorry. Yeah.
Echo alert.
Better now?
Yeah.
So what about all the other people in the that were maybe listening to the presentation? You have a question? You can also maybe ask a question in Chinese to Abao. He will help translating. My Chinese is not so good.
威弟有问题的话，可以问他，也可以问我。
So, in our new lab, one thing that maybe some of you have already heard, and one of the partners in the lab, she's working a lot with kombucha.
Maybe you can. Yeah, 红茶 drink.
Kombucha.
Maybe you can talk about a little bit.
What?
So I just thought about this. Just reminds me fermentation. So maybe this reminds me indigo dye is also fermentation. So but I realize you don't know about indigo dye process.
And so fermentation is a very broad thing. Fermentation means that some living thing, for example, a bacteria, produces something interesting instead of just like eating and living. And for example, these bacteria in kombucha, they produce this slime. And this slime is not cellulose. These are fibers, cellulose fibers that are much, much finer and smaller than the stuff we use for paper from the trees and plants. So also bacteria can produce cellulose fibers in the nanometer scale. And I've been experimenting with the material that Maya was growing to put it in different chemicals, just water. You see this? So this is also nanotechnology. It looks like alien slime, but it is cellulose produced by bacteria through a kind of a fermentation process that has nanometer fibers and pores.
So it's like doping stuff, what you're doing?
What did you ask?
if it's like called like the doping process, or it's like something different, like when you dope.
So now I have the cellulose matte, and I'm just trying a way to clean out the cells, because I don't want the cells in there anymore. If I have the material, I want the cells to be washed, to be dead, so it stops stinking. So I'm trying different washing, so that I'm only staying with the cellulose. And cellulose is a biopolymer, like a natural polymer. And if I put it in this one base, it gets really nice and white. You see, it's really white, transparent.
Nice.
And why is paper not transparent and this is transparent, although both is like made out of cellulose? Because these fibers are so small in the nanometer scale that their interaction with light is different, so it becomes transparent. So this is transparent paper. And this is a very traditional fermentation process. We just put some sugar and some nutrients in a pot, and we put some bacteria, and it grows this material. Takes 2 weeks. This is hydrogen peroxide, also very white, but maybe it will become brittle. So I'm testing a bit some kind of washing of this cellulose, nanocellulose material that is grown by bacteria. And now I touch the dangerous liquid, so I have to wash my hand.
So what kind of chemicals are you like using?
One is hydrogen peroxide, like this is what you use to bleach hair. And the other one is sodium hydroxide, but not too high concentration, but enough to wash and kill out all the cells.
And does it have like all kind of interesting properties other than being clear? Like with light or conductiveness?
It's not yet conductive, but of course I want to make it conductive.
Yeah.
And so it's kind of nice to make a substrate that's transparent when we grow it with bacteria. It's not a cheap or good way, but it's kind of fun to grow a material with bacteria that is transparent, and it's very strong. It doesn't rip so easy like paper. It's much more stronger.
Nice.
But then maybe we can paint some conductive nanotechnology on it to make it conductive on one side and not on the other. So it's still transparent, but also conductive. I think these gold nanoparticles or silver fibers or something that are so small. So if something is very, very small, it usually becomes transparent because light is too big to interact with this really small stuff, only on the quantum level. So I'm looking into this kind of as a substrate to experiment, maybe for electronics, but not really for a specific use, just because it's fun to do this, growing some bacterial nanocellulose. And by having more material soon, I hope I can experiment and come up with new ideas. I don't know yet where I want to go with it. I just want it transparent, clean, and white, and I want the cells to be gone, so it stops stinking, it stops smelling like vinegar. More like so I have it more, just pure cellulose paper, transparent. Anything else?
I personally want to know how to coat special materials on fiber, textile fibers, but I think that is a complex question.
You might so write it down. So for all the group, if you maybe find some information that is maybe technical material science, I do understand the language as well. I have studied. I don't have a lot of, let's say, experience in nanofibers because that was not my field, but still I do understand this kind of literature in material science and nanotechnology, and I can maybe translate it into a more understandable language. So if someone has a question throughout the next couple of weeks, I don't have the solutions, but I can help translating, let's say, the technical jargon from this kind of how to code textiles into an understandable language for craftsmanship and artists.
Nice.
Translate, you mean?
What?
Translate what?
I can
translate.
Because some of these technical, if you read a technical, let's say scientific paper, maybe if you're a craftsman, it's difficult to understand the language. And being a material scientist, I can help you. If you find something that you think is interesting, I can help you understand some of the technical terms. Also, maybe can say if this is something it's possible in do-it-yourself setting, or if it's something that is high-end kind of manufacturing.
Yeah, I guess like simplifying the process will help us a lot, because we're.
Yeah, I can maybe, if it's possible, I can help simplifying the process, but some of the process cannot be simplified. And so, because I do understand the language, I can maybe judge if this is something that we can do DIY or if it's something that we cannot do with DIY. Because I know a bit the technical terms and the stuff. So if anybody in the class has some stuff they may be interested, but they don't understand, they can send me and we can have a little discussion as a kind of material science translator into human language.
假如说，如果你对这些论文，或是你找到一些科技的论文有看不懂的话，可以寄给他，跟他讨论，他会把它翻译成人类的语言。
Anyways,
when I say materials, I don't mean, let's say, these traditional materials. I think there's enough other experts in this environment, but more or less these high-end, let's say, coatings or this kind of materials or special conductors, semiconductors, polymer fibers, stuff like this. I can help you to understand some technicalities and also help, if it's possible, that this can be implemented easy in a DIY project.
What do you say about this cadmium sulfide stuff? Do you think
to make light sensors?
Yeah.
I've been looked into it in detail.
It's like very toxic, I understand, like so.
Yeah, I just briefly clicked on the link you sent, but I have to look at it a bit more closely to give you.
Yeah.
Actually, it's very interesting because it was like used like a yellow pigment, in art and all kind of stuff. So.
Well, but this material by itself, it already is light responsive.
Yeah.
So, but then it's maybe how to process it, or can we use it as a coating, or what is your question?
It's like how to produce like a foil out of it. Like we need to make a foil.
Is it expensive?
I checked like in Israel and they don't have it actually in stock. We need to order it, and it's like went out of the I think of the.
And some of these powders, by the way, they might also be toxic if they're not processed. So I can also maybe help you on, if someone is unsure, I can look up. So every material you have, there's something called the material safety data sheet. But again, this has some cryptic language no one understands. But if there's a big red sign, usually it means there is some problems.
Nice. So we sure gonna talk with you. We are doing it all day already.
Yeah, well, we talk anyway. So me and Zohar, we talk regularly. So that's why maybe someone else can maybe say goodbye or say a last kind of comment.
I really appreciate your talk.
Too much information.
It was really interesting. It was like the first time I am listening to your talk, so it was really nice. But now it's like wait time.
You have to come here, Zohar. We make it happen.
I'm coming soon.
It's a little bit technical, but I think you already break down everything into simple level.
That's what I try. Thanks.
Yeah. As you said, it's really great to have some nano support in the team.
And so next time we can also come here to have a board meeting. This is the boardroom.
So, yeah, because of the time.
Yeah, I think we have to wrap up. If no one has a question, maybe it would be nice if some people say goodbye. I also have some other things to do soon. Or wait, I just say goodbye to everybody. So on this hack patch, I will share the slides and maybe also my contact information, so you can ping me up. I'm not so closely following the Slack, but I'm also in the Slack channel. So if you put my name, Dusseiller, I might get the message and then I can check it. But I'm not following it all the time like you full participants.
You can share your contact in the general channel or
yeah, exactly. I will do that. And I will also share the slides, but they're mostly pictures. They're not so interesting without just the story.
Yeah, thank you for the talk and the spirit.
Yeah, cool.
You are the best.
I'm looking forward that we organize a thing together physically with Aubao and you guys. After this online phase is over, maybe we can manage to meet on a beautiful tropical island, for example, Taiwan, and do a real life like material hacking, textile craftsmanship activity.
By the way, we are actually kind of organizing this solar cell plus indigo dye workshop, but I'm not guaranteed if we can do it. Yeah, we are trying to make this happen. Just
Corinna and Maya are there, so they will try to do this online indigo solar cell workshop. Nice. They're also over there, by the way.
蓝染加太阳能的那个工作坊。Cool.
Good. Otherwise, I think I'll stop this camera.
Thanks. Yeah. Any questions?
Still have this camera.
Yeah, but now we try to form the collaboration in the team and organizing workshops. In October, we will have a physical workshop in October. Now it's the end of the first series of talks. I'm trying to organizing 4 more talks. But at the same time, we should really start to share questions and interest, motivation to each other. And also we have so many supports. So just really want to make something happen.
Yeah, we're gonna present our techniques soon, no? Like from tomorrow.
Yeah, and everybody is professional. Yeah. So,
if I have time, I might drop in once in a while just to say hello and look what you have been doing. I'm really interested in all these projects. Just sadly cannot participate myself. I wish you good luck with your experiments, remote, local, friends, craftsmen, laser, material, something.
Yeah, the problem is everything is in remote mode.
Yeah, it's a bit of we need to invent everything again,
Yeah, exactly.
Like the physical stuff is like real hard. Yes.
Cool. Thank you everybody for joining. This is a bit late, so
thanks, Mark.
Thanks again. Thank you, Mark. Thank you, guys.
Bye.
Bye-bye.